Hi, my name is Manas and welcome to another OpenObserve video. Today we are talking about telemetry correlation. We all know the three pillars of observability, right? Logs, metrics, traces. On their own, each signal tells a different part of the story. Metrics typically shows you the trends. You can see where the spike is. While traces provides you with the complete request path and logs tells us what happened. It gives us the exact error message. But when things are actually on fire, staring at three different screens is just time consuming. Correlation between your metrics, logs, and traces should be as effortless as possible. Having them linked helps you focus on resolving the issue and not guessing or copy pasting fields like trace ID and timestamps just to piece everything together. All right, let's look at an example together. Here I am in my logs UI and I have data coming in from the hotel demo stream. This is an sample OpenTelemetry demo application. This is a regular e-commerce app, so you can expect services like checkout, cart, etc. Since I have all kinds of logs, info, debug, error flowing for past 1 day of data, let's filter it to look at error logs at the moment. I'm gonna go ahead, include it in the search term and click run query. Now, normally, this is where you go ahead and expand an error log message and you try to make sense of it. In this case, you start looking at the exact error message. There's a stack trace. Also, since you typically want to go ahead and search around this particular timestamp to actually understand what is happening with your system. And since my log records also contains attributes like trace ID, you can simply copy it, go to traces, paste it, and try to dig deeper. But instead, watch this. I have this view related button here. I'll click on this, go to traces, and boom, I have the exact life cycle of the distributed trace associated to that log record. We can dig deeper into the exact error span. And I know here's the service which is responsible, which is the accounting service for this error span. This is the power of correlation. You went from something is broken, a bunch of error logs, to the exact failing error span in one click. Here you can see exactly what was the database error which was leading to this error span. Let's look at another example. This is another common scenario. I have my NGINX logs and we can do similar things we did with our application logs, right? We can filter based on body, we can filter based on agent. What if I would ask you, can I get all the associated log records for this particular log entry? Once you go ahead, click to logs, it's gonna fetch me all the correlated logs right here. But what if these logs just tells me it was a timeout? I want to look at my infrastructure. How are my metrics doing? Right now, you can go to metrics with single click from your logs and you'll see all these metrics are automatically loaded for the exact container and the exact timestamp. And they are ready for your review. If you go ahead and want to select another metric, let's say I'll select container memory usage here, it's gonna give me a time series visualization of this specific metric. See, you have the log record, you have the associated logs, you have metrics, zero friction. But how does OpenObserve actually stitch all this together? To show you, let's look at the correlation settings for a moment. So we'll go to the correlation settings. If you have ever managed telemetry on your own, you know naming conventions are a mess. Your logs might call a field service underscore name, while your traces call it service.name, and your metrics are just calling it service. We fix this with something called semantic field mappings. If I'll tell you, in simple words, you just group these different variations of different fields or attributes into one single concept or one single semantic group. In this drop down here, you can look at some common environments, bunch of cloud providers, database, Kubernetes. Let's look at one of these together. So here we can see that there are different versions of the exact same field, which is the Kubernetes cluster name, and we have mapped them into a single semantic group. And users can always go ahead and configure these groups, different configurations for it. They can also set the priority order in terms of how the fields or dimensions should be managed at the backend. But OpenObserve handles all this translation under the hood. Since your data starts flowing, it links your logs, metrics, traces, regardless of how inconsistent your naming is. And this is the engine that makes effortless correlation possible. That's it for this time. Thank you for watching.